Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on aside as we jump into section 7.2 in the Big Ideas Math Integrated Math 1 textbook on box and whisker plots. Yet another portion of analyzing data from statistics and such has to do with the median, as well as maxes and mins, and some medians of medians, if you will. We'll see what we're talking about there in a second. Jump to the description section down below if you'd like to find the PDF of this, as well as the timestamps of each problem. We're only going up to the 20-something, 21 or 23 or something like that, so we'll see if it's a lot or if it's a little. I don't know. No matter what, we're here. Let's go ahead and get started. We're going to use box and whisker plots to represent data sets. I know that sounds really funny as far as what it is, but here we can get a quick sneak peek of what they look like. But this is what they look like right here, box and whisker. Interpret box and whisker plots and use box and whisker plots to compare data sets. So I don't know, we're probably going to graph some of our own, draw some of our own, I should say, like these. So get ready to not just interpret them, but also, yeah, I guess the use is us drawing them. All right. There's this other word quartile that we're going to have to use. These are basically medians, not medians of medians, but it's the half of a half kind of idea. If median is halfway in between, quartile are the quarter ways from your data points. Box and whisker plot being the other thing. 5-number summary is going to lay out all of those points in the box and whisker plot. And interquartile range is going to be a range just from your two quartiles as opposed to your max and min. Obviously, they're going to define these things for us, but these are phrases that you're going to have to know. You're going to have to use. So I want to call them out now. So when you see them highlighted, really pay attention, right? That's the thing here, especially if it's new for you. A box and whisker plot shows the variability of a data set along a number line using the least value, greatest value. So that's what I was calling max and min. By the way, I'm just going to pause in that comma for a second. These might be the words that they use because I didn't see them say max and min here regarding that. They might say least and greatest. I'm too habitual in saying max and min, and I think it's more common to hear that you're likely going to hear me transcode every single time that they say least and greatest into max and min. Min and max, respectively, right? Least is min, greatest is max. Okay, so a box and whisker plot shows it uses the min value, the least value, boom. The greatest value here, boom. And the quartiles of the data. A median is one of those quartiles. Quartiles divide the data into 4 equal parts. The median is the second quartile. So here's the first quartile at one end of the box, the third quartile at the right end of the box, and the second quartile is the median. You see 2/4 is 1/2. So that kind of works out in that way. The median of the lower half, boom, and the median of the upper half, boom, are right there. So they represent medians. Now you might be asking why this isn't an exactly symmetrical box and whisker graph. Why the first quartile is closer to the minimum than it is to the median. Why the third quartile is closer to the median than it is to the greatest value. These are representing the specific data values that you have. Remember, we have a list of numbers. They're not necessarily equally spaced out. You can have a clump of numbers that are all together here, and then ones that are more spread out there, including outliers. And these numbers, this is where our 5-number summary really lets us interpret where our numbers are centered and how much our numbers vary. So this is why we do them. It's not going to have equal spacing most always. Well, it depends on what data you're looking at. But it can be like this. The median does not have to be halfway between the least and greatest values, is what I'm saying. Anyway, this is called a 5-number summary. Min, Q1, median, Q3, and max. Those are the abbreviations I'm going to be saying there. Okay, making a box and whisker plot. So if you have this data not in order, you're going to want to put them in order. And putting them in order, you can find things such as the min and max. You can find the median. Median would, remember, in an even number of terms, such as this one right here, 6 and 6. You would find the average of those two values, the midpoint, average of 25 and 25 is 25. And then, like was stated before, Q1 and Q3, the first and third quartiles, are halfway between the least value and the median value. Now, when there are 6 terms, and I think I'm going to have to look at some of this again to be as a certain here, but the median, as you can tell, is not counting as part of your lower and upper half. When they say lower half and upper half, median's not a part of it. Median may be 25, but it's midway between these two 25s here. So as far as what we're looking at, some textbooks and websites are different. The median doesn't seem to be counting as a part of it, or at least median was calculated with it. We'll see more in a little bit on that. But you look at the lower half here, and halfway between 22 and 24 is 23. That is your Q1. Halfway between 28 and 30 is 29. That is your Q3. So for our 5-number summary, we got 18, 23, 25, 29, and 30, clearly not evenly spaced out. And we can draw a box and whisker plot that represents this. So you can put a point at the min and max ends. You can draw a box representing your interquartile range, and we haven't really gotten to that yet, but just from 23 to 29, draw a line inside that represents the median, or a segment there, and plot those points. So I'm going to try and draw them to match the same thing here. What I might have to be careful of or figure out is how to make everything equally spaced out. We'll see how we do that very well. I'm not necessarily particularly too good at that. So we'll have to figure out whether we should just make up where those values are or actually scale each part of it. That's the one thing I have trepidation on that I'm not sure if I'm going to be very good at unless they come up with graphs for us. Anyway, there's the drawing for the box and whisker plot there. Is that all we had to do I think that was all we had to do in the example. Okay, interpreting box and whisker plots. So here's what we're looking at. Within the spread, here's the lowest quarter of data, the lowest 25% of our data. And it goes from, well, they don't have the numbers anymore. Oh, this is a different graph, but it goes from the min to Q1. So your lower 25 is all represented within that range. And then here's the middle half of everything. That's the interquartile range, right? And they're going to talk about that here in a second. And then the upper 25% all exists there. So it tells you a lot with respect to where each quarter of your data is spread. So you can, I don't know, draw conclusions off that. So the interquartile range, IQR, is the difference of the third quartile and the first quartile. So how big this range is, from, I forget what the numbers were. Let's pretend like it was 23 to 29. That interquartile range would have been 6. 29 minus 23 is 6, and that's how far apart they'd be. So it represents the range of the middle half of the data. So let's see. Oh, yeah, see, these aren't they're equally spaced, but you have to come up with different spacings all depending on what there is. So if we have to draw our own like that, I don't know. We'll see how we do. All right, the box and whisker plot represents the lengths and seconds of the songs played by a rock band at a concert. Find and interpret the range of the data. So we have to find the entire range from the 160-second song to the 300-second song. That's a min and max there. 160 seconds is 2 minutes, 40 seconds. 300 seconds is 5 minutes, just so you know. The range is the difference. I'm going to kind of answer it for them first. It's the difference between their shortest song and longest song. How many seconds is that? So from 160 to 300, you subtract them and you get 140. The song lengths vary by no more than 140 seconds. The shortest and longest song are that many seconds apart. It's 2 minutes, 20 seconds apart. Part B, describe the distribution of the data. Now, the distribution is talking about that variation, right? The spread, what it is. So we get to talk about, let's see which ones they want us to explain. Each whisker represents 25% of the data. The box represents 50% of the data. So 25% of the song lengths are between 160 and 220 seconds. Where are they getting that from? First of all, let me move myself a little bit. They're getting that from right here, the first 25%. A quarter of the songs were within this realm. We're not seeing the exact points. We're not seeing the list of numbers. We don't even know how many songs that were played. There might have been, 8 or whatever. And 2 of them might have been here. But that's where that's spread out. 50% of the song lengths are between 220 and 280. So we're looking at the interquartile range. So that distribution shows this 50%. So about half of them. And the last 25% were played between 280 and 300. So to make sense of this, that doesn't mean that more songs were played here than were played here. An equal number of songs were played here. But their upper 25% is more jam-packed within just a 20-second difference, whereas this has a lot more variation from the first 25% of their songs, their shortest 25%, varying by 60 seconds, by a full minute. So there probably aren't too many songs that are in this range, or it's just spread out that way. So that's kind of how we can see that. The interquartile range, let's see, part C. Find and interpret the interquartile range. So that's the difference between 280 and 220, which is 60. So there's a 60-second difference in the interquartile range right there. That's what we found. Are the data more spread out below Q1 or above Q3? Explain. Well, I answered that a little prematurely, but they're more spread out below Q1 because there is a larger range of the lower 25%. So again, this 60-second difference. And if you notice here, guys, the 25% right here is the 60-second difference, and this 50% is a 60-second difference. They have equal ranges here and here, but this is double the number of songs. You know, if half of their songs are between here and here and a quarter of their songs between here and here, there's a lot more spread of the points in that lower Q1 versus especially this set, Q3, that's just a 20-second difference. So we're going to have to understand when they ask for distribution, they're talking about the below Q1, above Q3, and the IQR, the interquartile range. Sometimes these lectures are good for me to look at again just to make sure that I'm answering the way that the book would ask us to. Although I'm using the words min and max instead of least and greatest whenever I can. Use box-and-whisker plot, a box-and-whisker plot shows the shape of a distribution. So I mentioned that symmetry thing, right? There's symmetry with this one. Even if it's not equal spread, maybe this isn't the same amount of spread as this, but there is symmetry here. The whiskers are about the same length. The median is in the middle of the plot. And they're going to do enough to kind of tell us what that looks like here. Now, this is skewed left versus skewed right. I know where people might confuse themselves in thinking that this is skewed right and this is skewed left, and sometimes I would make that confusion as well and make sure to make the distinction. When it's skewed left, the left whisker is longer than the right, so most of the data are on the right side of the plot. Everything's jam-packed in here, whereas this stuff spreads out more to the left, possibly to outliers to the left side. There's that skewed left. Skewed right is the other way. So most of the data is on the left side of the plot, or data are. I forget data is a plural word sometimes. For datum. I think I even say data more in the like British version. Oh, we have it all data. Data is more the Americanized version. Sometimes you'll hear me say data, but I'm being proper. All right. Comparing box and whisker plots. So the double box and whisker plot. Ooh, there are two of them represented here for your class, your friend's class, and test scores. So identify the shape of each distribution. If I look at my class, I'm looking at something that is clearly asymmetric. Maybe these first three have symmetry in such a way, even equal distribution and length for each quarter. But boom, that left whisker, and this is something like what my classes would look like. Not by min and max, that just you'd get more spread on that lower end in such a way just because there are some that really hits a minimum that's going to spread out more than those who like studied or whatever. But here, this is left skewed. This is a left skewed thing in my class. So the left whisker is longer, and most of the data are on the right side of the plot. So for ours, we are skewed left. For my friend's class, y'all, this is even distribution. I mean, as even as one could get, pretty much. 60 to 70 is 10, 70 to 80 is 10 as far as range. 80 to 90 is 10, 90 to 100 is 10. Everything is equal length. Everything's symmetric. Your friend's class is symmetric with test scores. For better or worse, they're symmetric with test scores. So more... your friend's class is symmetric. Part B, which test scores are more spread out? Explain. This is all about the range. Although there is some great spread for my first quarter there, everything else is jam-packed in such a way, and from 100 to probably around 67, 68 or whatever, 67 and a half is mine. That is a lower range than my friends, which is from 100 to 60 or 60 to 100. Their spread is 40, right? Greater spread there. So my friend's class is more spread out for test scores. They're also talking about the interquartile range. Even the interquartile range right here, just the middle 50%, that is a range of 20. And this is a range of 10 right there. So a double thing, right? Okay, I'm always skipping examples here that after they do those just so we can move forward. And that is it for the lecture portion, guys. So we only have, we still have to do this part 1 and 2. But after this, we only have like 20 some odd problems to work on. So let's take a look. Describe how to find the first quartile of a data set, first quartile. You have to find the difference. So the first quartile is the Q1 or Q1. You need to find the median, and I'm quoting this, the median middle value between your least value, minimum, I'm going to say minimum, and median. So this is, here, I'll call it a lower median. The lower median, the middle value there. So, right, halfway between. Now, they didn't do extra versions of this, and I'm actually going to pause for a second to find it to be sure. There are some classes. Here's what I'm going to state right now. The list we looked at had an even number of terms, right? In the first example, there were 12 terms with 6 and 6. The median was technically not even one of the data points. It was just a data value that we pulled out by taking half of 25 and 25. But if you saw that the lower value and the upper value were doing their own thing because it was 6 and 6, so the lower value is halfway between that, halfway between threes, etc. We didn't see an odd number of terms. And the odd number of terms, let's say there were 9 terms. The middle value would actually be the 5th term. Now, there would be a lower and upper half, which there are some statistical, websites, books, whatever. There are some things when they're taught that the median value counts, that the lower half is actually terms 1 to 5. And then the upper half is terms 5 to 9. I'm of the belief, and I'm going to check on this, on what's mostly defaulted or whatever, or through some examples here. I'm going to check and see. I believe in that case of that, the lower half would actually be terms 1 and 4, and the upper half would be terms 6 and 9, and then you'd find the median for that. So let me check on which one they want to do before I explore this further. All right, give me a second. Okay, so just as a quick confirmation, what the book will probably want, the median is not used in the lower and upper halves when you have an odd number of terms, such as that. So we're going to keep that in mind when we do our problems. Okay, anyway, I'm going to move forward and look at number 2 here. Number 2, different words, same question. Consider the box and whisker plot shown, which is different, find both answers. So there's like an A versus B that I generally do here, right? Find the interquartile range of the data. So the interquartile range would be the difference between the 20 and 11. That's the middle 50%, and that is 9. So in case we have to use that. Find the range of the middle half of the data. That's the same information as interquartile range. The difference of the greatest and least value of the data set, that's the range. That's from 24 to 1, and that's 23. That's the different answer to me there. Find the difference of the third and first quartiles, the interquartile range of that middle half. So this is the different one. These are the same. This answer this is 9, 9, 9, and that is 23. Y'all, there's an outer quartile range and inner quartile range, I suppose. All right, guys, we are going to do, let's see, numbers 3 through 23. So 21 problems, not 20 problems. 21 problems to do. Jump down in the description section down below if you want to find these problems for yourself, as well as timestamps to each individual section that I'm going to do. Let's go ahead and get started. We are going to take this box and whisker plot. I'm not going to redraw it. I'm just going to keep it where it is. To find the given measure. They want us to find the least value. I'm just going to go ahead. I feel really bad for this that I'm not writing least, but I am going to be calling it the minimum. Whatever I do it. That's what I go to. That's what I believe a lot of books and sites and stuff like that will go to. I can't guarantee. Some will say least value. I don't know. Maybe I'm talking out of my arse when saying that, but I'm going to go for minimum. So least value is the minimum. On this graph here, this is the least value. This is 3, between 2 and 4. So we're there for 3. Number 4 is the greatest value being the maximum value. And I do apologize if, I'm not apologizing to the book guys, but I'm apologizing to you guys if obviously your teacher's going to say least and greatest, but I'm really kind of teaching toward anybody who would be interested in hearing this, and they'd probably hear it the other way. So anyway, 14 is the maximum value here. Number 5, the third quartile. It is, again, the median of the median. It is the right end of this box here. That's between 10 and 12, which is 11. That is what I'm going to be denoting as Q3. Q3 is 11. Number 6, look at this. We're going to get 6 problems out of the way just like that. The first quartile, Q1, is 6. Boom. So we're drawing that down. So that is 6 for Q1. And then number 7 is the median. Median is that middle value in the box and whisker plot. And that is this 8 here. Put med. So no mean here, right? No average value. Just median and such. Now, sorry, range. Let's answer this first. Range is between 3 and 14. Range is 14 minus 3. Not the interquartile range. The range. The ones that we were doing from even... Ooh, why did my pen thing change? The ones that we were doing from section 7.1. The range... I'm surprised they didn't actually pull up by QR here. is 14 minus 3, which is 11. So I'm just going to go ahead and box all those up. What was I going to say? Oh, 5-number summaries, because I don't know if they'll mention this. This is just you practicing how to calculate the things. 5-number summaries are really good to use for data that have asymmetrical spread. Because just to explain things are distributed by 25% each and stuff like that, we have other ways to do things when they're symmetrical. More symmetry, it's better to use mean and standard deviation as your values of center and variation. Five numbers, when you have your stuff that's more varied and asymmetrical and things like that, 5-number summaries are better to use alongside range and IQR. So median, Q1, Q3, min, max, and range and IQR can all be spoken on there. So those are better to use when you have lack of symmetry, when you're describing a spread. Okay, exercises 9 through 12, make a box and whisker plot that represents the data. So now we have to do this here. Based on the numbers, I will try my best to form kind of like an even spread of number lines. I'm going to use my line tool to just draw the line to begin with. But hours of television watched. So I'm going to write out the list. So we got 0. I'm going to write them in order now. 0 is the smallest number. Then we have a 2. We have a 3. We have 2 4s. 2 5s. And a 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. All right, I got them. All right, so here are our data points. Now, to do the 5-number summary, it's best to to do the box and whisker plot, it's best to pull out a 5-number summary to begin with. What is the min? What is the first quartile? What's the median? What's the second quartile? Or the third quartile? And what's the max? Right here. Min and max, easiest to answer there, are 0 and 6. Median is halfway between the two middle values, so 4 and 4, which is 4. Now, the lower half here is from 0 to 4. The upper half is from 4 to 6. The Q3 is a little easier to answer. Between 5 and 5 is 5. And between 2 and 3 is 2.5. I guess that wasn't hard to answer, but that was the same number, and this is adding them and dividing them by 2. So those are the values here. So when we do our our box and whisker plot, we use our 5-number summary to make that. So I'm just going to go ahead and draw a line here. I'll try and do as equal spread as possible. I got to go from 0 to 6. 0, 1, 2, 3, 4, 5, 6. And let's get her done. 0 is our min. 6 is our max. Our interquartile, where we draw our box from, I'm going to reshape my tools here. I know you probably have to do some fill-in and stuff like that, different from me. But our interquartile goes from 2.5 to 5. So 2.5 is about here. And I'm going over to 5 right there. I want to make it look a little better somehow. I don't know how, but I'm just going to draw it like that. And then we connect here. I guess if I used full pencil mode, I would probably make it look a little different than what's represented. So maybe next time I will. To make it look probably nice. And then your median is 4. Your median is 4 right here, which is that guy. So that's the box and whisker plot that's represented there. And that probably took longer for me to try and use all my shape tools to make that so. But that is your box and whisker plot for that one on number 9. Okay. Oh, sorry. I got to actually put the points there. Next time I'll just put the points on where they fit, and then I'll just draw the box afterward. Okay. Number 10. Cat lengths in inches. Smallest number, is it 16? Yeah. Then there's a 17. We got an 18, folks. No 19. There's a 20, a 21, 22, 23, 25. Let's count that off. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, I think I got them all. Okay, here we go. Let's get our 5-number summary. Now, did they say the phrase 5-number summary? I think they did. So I hope that doesn't sound like, hey, he's making this up. What is this thing? I think that's something that they said. That's something that I would say as well. That's what this is called. Here's your 5-number summary. Let's get it displayed first. We got 16 and 25 as our min and max. Median is again going to be halfway between, say, the 20 and 21 there. So 20.5 will be the median. And then this is 8 terms once again, so split lower and upper halves to 4 and 4. And you're going to take halfway between 17 and 18 and between 22 and 23. So these are all half values. 17 to 18 is 17 and a half. And 22 to 23 is 22 and a half. So outside of me drawing just a line for, for the number line part itself, I'm going to try and pencil sketch the rest of it because you probably aren't using a bunch of ruler things to draw these out. 16 to 25, I can count those out with 10. It's just 10 increments. 1, so 17, 18, 19, 20, 21, 22, 23, 24, 25. A little bit of wiggle room. There we go. Okay. Not proud that I have to come up with these graphs myself, but okay. Min and max as they are. Now, you know, sometimes I might even spread it out a little bit more if there are less things I have to write just to show like, hey, here's more information that we never included. Like on that test scores things, it's good to show kind of that 0, even though we never hit 0, we only hit 60. And it's good to show a lower end and say, hey, this was all, there's no data here. You know what I mean? But we're really interpreting what's going on here. Now, let me draw the points before I do any box-based things. So 17 and a half is here. That is our Q1. 20 and a half is our median. And 22 and a half is our Q3. The box goes around with my pencil. Q1 to Q3. I'm going to draw some whiskers on this thing. Right there. And then there's the median. So there's more of a rough sketch version of it. And I kind of like that version a little more than this one. That's a little too clean and a little clean and messy at the same time. Different levels of transparency. That thing's a little lifted. I kind of like what I'm dealing with there. I have a paint tool. I've never used it, but I want to see if this would fill in. Let's see if I hit the fill in button. Oh, it's not filling anything in. Never mind. I thought it was like the paint software that you could actually fill in something that's enclosed, but apparently it didn't work there. Okay. Number 11, elevations in feet. I never really think about being certain just 4 feet below sea level or something like that. But -4 looks to be the smallest value. Remember, start with your negatives. There are 2 -3s that I can see. I see a -2, no -1s. I see 2 zeros. Any 1s? Yes, there's a 1. I see a 2. I see 2 2s. I see 2 2s. I see no 3s, no 4s, a 5, and a 6, I believe. Let's count that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Which is good to get an odd number here. All right, got all 11. Okay, so yes, always display them in that order. Please, please, please. Min Q1, median Q3, and max. What does this information have to say? All right, we got a -4 to 6. That is a range of 10. Q1, before we do Q1, Q3, you really want to hit median first. So there are 11 terms. There's a lower half. Well, I'll still speak on lower and upper half. There's a lower half of 5 terms and an upper half of 5 terms with the median in the middle. 0 is your median. 0 is not, I mentioned this before I started, this number's 3 onward. The median does not count as a part of your upper and lower halves when you're tracking all that data there. So now it's just the lower 5 and the upper 5 with a middle value, but the lower 5 has the third term be the true Q1 and the 11, 10, 9. The ninth term, or the third term within the upper half, has the Q3 value. So our Q1 is -3 and our Q3 is 2. By the way, you might ask at some point, is it possible for the Q1 and the median and something like that to be the same value? Absolutely it is. And I'm sure we're going to run into that at some point. But it is very possible for that to happen. Okay, this goes from -4 to 6. This time I'm going to go a little more like, I'll put -5 here. and then -4, -3, -2, -1, 0. And I'll just count up until I run out of room. 2, 3, 4, 5, 6, 7, 8, like that. Just to kind of do 4, 3, 2, 1, 0. I'm just going to put numbers here. 1, 2, 3, 4, 5. And then see if we can do it based off that alone. So -4 is the minimum, which I put -5 at the end. So -4 is here. 6 is up here. Boom, there's our min and max. Q1 is -3. And actually, that's just right here. So our first whisker, our left whisker, is right there. Boom. And 1, 2 is Q3. So here's our right whisker. And then, so we can draw a box around that. I haven't gotten the median yet. Just getting the box and whisker stuff on. And 0, boom, is the median right there. So there's kind of a nice version of it too, because I'm not writing every single number, but I'm still representing every single number. We still know what's what. We're all good. And there is your box and whisker plot. Number 12 is on MP. No one knows what an MP3 player is anymore, even though this book was made in, what, 2014? MP3 player prices in dollars. And second of all, if they do exist, they'd be way cheaper. Well, actually, now that they're so antique, they probably would be more expensive. Like, it's like buying, what is it? Like Super Nintendo games now are like $80 or something. Or whatever, $40. It's not like they're $4. Things that, you know, jack up in price again. The smallest value are those ones that are less than 100. We got a couple 95s going on. So 95. So let me count how many numbers there are before I do this, just to confirm. I got 5, 9. So I'm looking for 9 total numbers. That's 2 of them. 100, 105, 110, 114, a couple 124s. That's 7 numbers so far. 2 more. 190 and 300. Okay. Also an odd number of terms here. So the middle value will be the median. That is the 5th term. Okay. So min is 95. Max is 300. I don't think they've asked for range or anything like that yet, right? They've just been having us do this. Median is 114. Now this time, your upper and lower halves have 4 values, an even number, instead of 5. So we have to take halfway between 95 and 105. You can imagine that'll be 100. And between 124 and 190, maybe you can't imagine that as well, but we have to find halfway between. We have to add those up and divide by 2. That's one way of kind of coming up with it. The way we've proposed before, so I think it's 314. 314 over 2, which gives you 157. So Q1 is 100. Q3 is 157. Now, if I were to do a box and whisker plot here, clearly I'm not going to count by 1s. I might not even count by 10s. I might count by 20s here. Because we have to go 10s, 9. That'd be a lot of terms there. I'm gonna go by 20s. This might be a little bit more hectic, but I'm gonna put 80 on the low end and go to 100, 100, 120, 140, 160, 180, 200. 220, 240, 260. Ooh, I ran out of room. See, even going by 20s, this is pretty. It's going to be pretty densely packed. 100, 120, 140, 180, 200, 220, 240, 260, 280, 300, 320. So here's 200. Wait. 100, 120, 140, 180. Oh, I counted the wrong. Wait. No. I must have counted something wrong the first time. 120, 140, 160, 180, 200, 220, 240, 260. Oh, that is 300. Okay. I did something a little different the first time. Okay. I'm going to erase the 80 just so I'm only putting the hundreds on there. So let's still do this. You know, this is 80 though, right? These go by 20s. So 95 is actually 3/4 of the way from 80 to 100. So it's closer to 100 than it is. It's not halfway in between. 100 is Q1. They are right next to each other. That whisker Boom. That is a small whisker there. A lot of points densely packed in between. Well, they're actually not a lot of points. Yeah. Okay. Anyway, remember, there is no actual 100 value in your data. You want to remember that. There is no actual 100 value data point. The median is 114. This is 120, and 114 is closer to 120 than it is to 100 in the same way that the other one's represented. Now we're jumping up to 157, so 120, 140, 160. That's pretty much right near 160 like that. That's your Q3. And then 300 is way over here. So talk about a skew of data. I do have to draw a long whisker here. And then I'm going to draw a little box right there. Here's your box and whisker for this guy. Way different kind of data for that one. I wrote the 5-number summary on the side, but that is our set there. Very right skewed. Very right skewed. Give me 1 second here. Okay. If there's one thing, what I didn't copy down information-wise is the context. So if there's one thing that I should probably kind of fix within that, maybe not copy that down per se, but on this graph itself, you should probably be saying what it's at least representing, at least the values. So like this one was MP3 player prices. At least I just want to say like price in dollars. Dollars. Because I was thinking about that. I was like, we're doing box and whisker plots, but I want to go back and look at those. So this is elevations in feet. Elevations? I guess so. It's multiple. Feet. I like representing things contextually whenever we can. Number 10 was cat lengths. I know what that means, but like whatever that means, you know what I mean? And then hours of television watched. This is TV watch hours. Okay, let's move forward. Number 13. Analyzing data. The dot plot represents the numbers of hours students spent studying for an exam. Make a box and whisker plot that represents the data. And the reason why I wanted to bring that stuff up for these things here is because here I saw hours. And I'm like, contextually, we might need to say something there. Okay. Now, I don't think we've seen a dot plot in lecture-based portions. I do remember, I think it was in 7.1, the how do you see it question, which showed some dot plot things. I think that's the one that it was. It had to do with like bowling. Maybe I'm confusing two different problems in context. But a dot plot shows the frequency of how many times values occur. Now, I'm kind of hoping, I don't see it, I'm kind of hoping number 14 is also a dot plot, so I don't have to do this specific thing again. But I'm going to write out the lists of the values that there are in order, which is going to be easy. There are 2 zeros, 4 ones, 6 twos, 3 threes, 2 fours, 2 fives, and a 7. Within here, we can do the exact same stuff as we'd done before. There's a 5-number summary and all. Min, Q1, median, Q3, and max. Now, at the thread of perhaps let me look at number 14. Yeah, it's not. There's a stem and leaf plot, which can be kind of similar, but at the thread of not having seen a dot plot on the next one, I wanted to make mention that you can figure out these values here you still have to count how many things there are by adding 2 plus 4 plus 6 plus 3 plus 2 plus 2 plus 1, and then kind of figure out where those middle values lie and things like that. But this works. You just have to write everything out. So the minimum is 0. The maximum is 7. Almost seemed outlier-esque since there's no 6, but not really. That's not an outlier. All right. How many values are there? I probably should have added these, so let's do it. 2 plus 4 is 6, plus 6 is 12, plus 3 is 15, and then 17, 19, 20. So there are 20 values. So the 10th and 11th values are the middle, not the 10th, but the 10th and 11th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 and 11 here. Average of 2 and 2 is 2, which represents the median. Now, the lower 10 from 0 to this 2, and the upper half right here, 11 to 20 are right here. Terms 5 and 6 represent the median. Excuse me, Q1. Between terms 5 and 6 here. So that's going to be 1 for Q1. And between 1, 2, 3, 4, 5, 6 right here represent Q3. So that's going to be 3.5. So now we can make a box and whisker plot off that. 0, 1, 2, 3, 4. Ooh, that's a little more spread than I'd want it to be. Whoa, come on now. I didn't want to undo all that. 5, 6, 7, 8. Why not? 0, 1, 2, 3. Okay. Here's our min and max. Q1, median, and Q3 is at 3.5. Got another right skew here. Box and whisker. All right. This is an hour still. If they said hours before, I might as well say hours now. Studying for an exam. Who spends 7 hours studying for an exam? But see, that's the thing. Barely anyone does. There's much more spread in that upper 25%. We haven't interpreted anything yet, but we got to get ready to. We got this next thing here called a stem and leaf plot. Now, they're giving you a key to represent how this thing works, but it's all about digits. This is the tens place, and this is the ones place for these things here. So we'll get to that in a second. The stem and leaf plot represents the lengths in inches of the fish caught on a fishing trip. Make a box and whisker plot that represents the data. So I almost feel like I have to write this list out for you again so you can understand what this stuff means. You have the singles digits values here again, and the tens digit is 0. Therefore, you actually have the numbers 6, 7, 8, 8, and 9. So 6, 7, 8, 8, 9 are these values. And then these are 2-digit numbers because this is like 10, 10, 12, 12, etc. So I'm going to write all those out. So 10, 10, 12, 12, 13, 14, 14, and 17. Make sense? And then the last ones are 21 and 22. Now we can count off this and do that. I can also count from these ones as well. So there are 5 plus 8 is 13 and 15 total. If there are 15 total, the middle number is 8. So 1, 2, 3, 4, 5, 6, 7, 8 right there. So that's going to be 12. 12 would be your median. There's a lower 7 and there's an upper 7. Within the lower 7, the fourth term, 8, will be your Q1. And the fourth term among this 14, will be your Q3. So I am determining the numbers there as well as we can find them right here. This 12 is the median. And this is your Q3. This is your Q1. Those are the values that I was kind of pointing out there. So minimum, 6. Q1, 8. Median, 12. Q3, 14, and max, 22. See, I wouldn't have written this out except for it's our first time interpreting such a thing, so I wanted to do that for you. Otherwise, I would have just left it with the stem and leaf plot and did exactly what I did. Just kind of found the numbers from there. Going from 6 to 22, let's go by twos. So 6, 8, 10, 12, 14, 16, 18, 20, 22. 6, 8. All right. 6 is our min. 22 is our max. 8 is Q1. Median is 12. And Q3 is 14. All right. Box meets whiskers. There you go. This is lengths in inches. Length in inches. Another right skew, if you will, at least for the last 25%. In the middle, there's a little more, I don't know. It's data. Good thing we don't have to interpret that one. Okay, analyzing data number 15. The box and whisker plot represents the prices in dollars of the entrees at a restaurant. So, how much they're priced at. So, for number 15, part A, find and interpret the range of the data. The range is going to be the difference between the max and min, right? So the range is going to take that max value is $18.25, which that's what they're talking about here, minus the min $8.75. So when you subtract those, what's that, 950? Well, it's 9.5, but I'm going to put that in context. So the range says what the difference is between the highest and lowest price items. They said it kind of differently. They said something like the range the prices differ by no more than, or something like that. But I'll just say the difference between the highest and lowest prices, the highest and lowest priced items, is $9.50. That's what I'm going to that's my version of it. Part B, describe the distribution of the data. This is where they talk about the lower 25%, the upper 25%, and the interquartile range, the middle 50%. So 25% of, I'm going to type these out. So I got a bullet point feature thing I can say here. So we're stating kind of what they are between. So 25% of the data, or of the, not the data, the prices. 25% of the prices are between, and then we're going to talk about the first quartile range, the 875 and 1050. And then 50%, that middle, 50% of the prices are between 1050 and 1475. 1050 and 1475. A lot of numbers to deal with here. And then the other 25%, the higher upper 25, are between 1475 and 1825. That's contextually based since we have to put the dollars and stuff. I want to shrink that a little bit, though. It kind of bugs me that they're written like that. All right, we'll just use that. Okay, part C, find and interpret the interquartile range of the data. So that's that middle 50%, right? The middle half, if you will. So the IQR is what we'll call that. It's what they call it as well. 1475 is Q3, and we're subtracting the 1050, the 10.5, which is 4.25, right? So the middle half, that middle 50%, has a price variance of 425. How do they say it? They say, I think they said they vary by no more than, or something like that. Vary by no more than $4.25. Because I have no better way of saying that at that point. The difference between the middle half of the prices is just kind of weird when we say it that way. So part D, I guess they had a good way of saying it. Part D, are the data more spread out below Q1 or above Q3? Explain. Based on the Box-and-Whisker plot that we see here, this range between 875 and 1050 is less than the range from 1475 and 825. So this larger range means there's more spread. So therefore, there is a larger spread. It's just comparing the whiskers. These are evenly scaled values. These go by ones each time here. So just use a ruler, measure which one's longer. That's all we really got to refer to, which whisker's longer. So above Q3, the data is spread out above Q3 because it has a longer whisker. Now, I mentioned this back in 7.1, but there's no one data value that answers everything, including Box-and-Whisker plots, although it says a lot. But remember, we don't see the actual prices of anything here. Obviously, there's a min of 875 and a max of 1825. These 1050 and 1325, etc., remember, we've seen these might not actually be actual price items. These might be halfway in between two price items, which is just something we have to compromise with, right? That's the thing. But we don't know how many items there are that are being priced right here, right? This is just a 5-number summary of all that stuff. It tells us a lot. It doesn't tell us everything. But it does. It tells us a lot. All right, let's move forward. Let's go to number 16. Analyzing data. A baseball player scores 101 runs in a season. That's a good season. It's not the RBIs, though. It's how many times they crossed home plate. The Box-and-Whisker plot represents the numbers of runs the player scores against different opposing teams. Okay. Find and interpret the range and interquartile range of the data. So on 16 part A, we have a range as a whole of, I'll put equals, of, that max is 17 and min is 0, so that's 17. So in terms of interpreting that, the difference between their most runs scored against a team and least is 17. Runs, that is. Now, if you don't know much about baseball, they have what's kind of, they've balanced it more, but it's what's called an unbalanced schedule. Circling back to kind of pre-COVID times, pre-2020, etc. You would play certain teams like 18, 19 times in a year against your division. And there are some teams either you wouldn't play at all or you'd only play 3 times kind of at most when they're not in your, 3 times if they're interleague, 6 times if they're, maybe 6 or so times if they are not in your division, but in your league. And so the 17 max, just this has nothing to do with the problems themselves, just baseball. Why would they score less here and more here? Is it just that they're really good against this team and really bad against this team? Maybe. But also just that there are some teams that are going to play significantly more, maybe 6 times more or something like that at most. I don't think they're counting 0 against teams they didn't play. They're like counting teams that they did play. And maybe he didn't do too well in those games. Anyway, just wanted to bring that up. Describe the distribution of the data. We're going to do the 25% stuff again from before. So let's say how 25% of the runs are between this and that, 50% of the runs, etc. So 25% of the runs scored against opposing teams. Let's see. That's a lot of information. I'll just say runs scored are between 0 and 2. Somewhere he scored 0 and 1 and 2, things like that. 50% of the runs scored are between, now check Q1 and Q3. This is 2 and 9. And then 25%, the upper 25, are between 9 and I think it was 17, right? 17. There it is. Okay. Let's minimize that again. So that's our distribution of the data, which shows, again, more densely packed. The 0 and 2, let's say they're playing 20 different teams in the year. That sounds pretty commonplace. 20 different teams in the year. A lot of the times, not all of them, but not a lot of the times, I should say, there are a lot of instances of 0, 1, and 2 runs scored, likely. Didn't score very many against a quarter of the teams they played. And then there's a big spread there. That doesn't mean there are more runs. There's an equal number of sets between here and here. Keep that in mind. That's why we say the percentages there. And then 50% being in the middle. Part C, are the data more spread out between Q1 and Q2 or Q2 and Q3? They're not asking about the whiskers. They're asking about the parts of these parts right here, between this and that. Whichever one's longer is the answer, and that's between Q2 and Q3. That half of the box is longer. So on 17C, the data are more spread out. I might have said is last time. Are more spread out between Q2 and Q3. Not A3. Because that half of the box is longer. It's weird to say half, given that it's not represented half by distance, but it is half by amount of numbers that are there. You know, we could do ranges there. This is from 4 to 9, which is 5, and this is from 2 to 4, which is 2. So 5 versus 2. This is not how many data values there are. This is how spread that range of data values are. Number 17. The double box and whisker plot represents the monthly car sales for a year for 2 sales representatives. Again, I'm not going to redraw them. We'll keep them where they are. Let's go to part A. Identify the shape of each distribution. For sales rep A, I'm going to call that very symmetric. It is a symmetric distribution, very even spread of your values, and like even distance, I should say, even distance of the spread of your values here. That's just the nature. It doesn't have to be very identically symmetric, but it is in that way. In sales rep B, this whisker is shorter than this one. This box is less than that one, so there's much more of a right skew here. That spread favors the right side. Not favors the right side. There's more spread in the right side of values more, so that's what we'd call right skewed, or I think it's a skewed right. Skewed right. So that's what I'm going to say there. Part B, which representative sales are more spread out? Explain. Sales rep B. B is more spread, both by range and IQR. I'm not calculating them just yet, but we can see that visually. Range and IQR are both bigger. When both are bigger, there's no argument to it. When one's bigger than the other, we'd have to talk a little bit more about it, but here I think they're going to make it quite obvious. And if one's more spread out in one, it's likely to be more spread out in the other, just by probability. Part C, which representative had the single worst sales month during the year? So I assume it's going to be B here. I think they're just talking about just an individual data point, and this one has a lower minimum than this one. That's just around 8. It looks like those are about in line, maybe a little lower. But sales rep A has a min of 8, and sales rep B has a min of 4. So sales rep B, because its min is 4 versus the min for A. I'll put min B versus min A. Min A looks to be... I can't tell if it's right on 8 or less than 8. Does it look like it's a little left? If I drew a straight line down here, is that right on, or up here? Are those the same? I think, okay, I think those are the same. I couldn't tell if it was like 7.99. Min A is 8, but B is the lowest. What'd they say? The worst sales month. They make it sound really disparaging. The single worst sales. All right, error analysis. Describe and corrects the error in describing the Box-and-Whisker plot. Before I read it, I'm trying to think of what they say, and I can't come up with it. Maybe they say the IQR is the range. I don't know. Maybe they'll call something left skew when it's right skew. Let's see. What will they say? Yep, it's about skew. So let's see. The distribution is skewed left, so but they're talking about this. Most of the data are on the left side of the plot. The data is evenly... I'll explain that in two ways, but I'm going to write it a different way here. So they're correct that it is skewed left. They're correct. This part here is good. When they say most of the data are on the left side of the plot, what we're talking about is, if you were to divide things evenly within the range, meaning what's half the distance between this number and this number, I don't know, probably somewhere around here, right? But you can tell that there is actually less data here on this line. There's less data represented here than there is here. This is more densely packed. Remember, this is the spread of 25%, 25%, 25%, 25%. So you have from this 25% right there, a lot of it is actually within this part of it. So here's 50% of the data. Here's some percent of the data that's more than 50. Maybe it's 60 something percent, whatever. And then here's that excess, maybe 40 or less some percent that's represented there. So this is more than 50% represented here. There's less than 50% represented here. Remember, each part of this is exactly 25, 25, 25, and 25. But when distance-wise, it's kind of spread. So when they say most of the data are on the left side of the plot, that's incorrect. Most of the data are on the right side of the plot. Now, that does make it skewed left, are on the right side of the plot because the box and whisker diagram is more densely packed. They are correct, however, that it is skewed left. Okay. Number 19. Given the numbers 36 and 12, identify which number is the range and which number is the interquartile range of a data set. Explain. 36 has to be the range because range has to be greater than or equal to the interquartile range. Interquartile range has to represent something within, which has to be a smaller value. It can be equal if Q1 and Q3 are the same as the min and max, respectively. But kind of a weird question, but I guess it's important to know. But the range must be 36 and IQR equals 12. Range must be greater than or equal to. It's likely going to be greater. I personally have not come across in a math problem before the IQR that's equal to the range, but it's possible to have. I just want to make sure we know that. All right, number 20 is how do you see it? We actually have 4 problems left. We'll see how large they get. They might get a little big. How do you see it can be a little smaller sometimes. Although we have 4 parts. The box and whisker plot represents a data set. Determine whether each statement is always true. Explain your reasoning. So if not, we'll call false. We'll say yes versus no. Yes, always true. No, not always true. The data set contains the value 11. 11 is this maximum. That will always be true. So yes, always true. It is a max value, right? 11 is the max. Part B, the dataset contains the value 6. Not necessarily. There's nothing that can guarantee. It's within the spread here. That doesn't mean 6 has to be landed on, right? It's not even part of your 5-number summary. But even then, that's not necessarily true. No. There could be. For something that's not always true, you should probably do it like a counterexample, like give a list of something that wouldn't work out. I'd have to make sure it's if like 5 was the median, which isn't a guarantee. I could have 2, literally, I'm just going to write these numbers, 2, 4. Oh, then that wouldn't be the, I'm not going to do a counterexample. I have to think too hard on that. 6 isn't guaranteed. I'll just say not guaranteed data point. And if all of these are going to ask those things, right? I probably have to say that each time. The distribution is skewed right. For this particular plot, yes. It doesn't matter what data is involved. For the plot of this thing, this is skewed right. So no matter the values, no matter the data, like the actual numbers that we have here, the diagram shows a right skew. I'm saying that the data within can be kind of tricky, whatever, but if that's your min and that's your Q1 and median, Q3 and max, then that is a right skew, period. Part D, the mean of the data is 5. No, this is the median. The mean is not always the median. And in this case here, the mean is likely going to be larger. The mean is likely going to be larger. So no, mean isn't equal to median necessarily. Not to mention, the mean is likely greater here. Not always, but in this particular instance with the right skew, I'm not going to call them outliers, but because this max is pushing values over, it's increasing the average just by being a larger value. Okay, it's pushing the average over by being a larger value. Number 21, analyzing data. So you can see we're ending on a lot of problems, or a lot of things to do here. The double box and whisker plot represents the battery lives and hours of 2 brands of cell phones. So this is, I guess, different. Is this different people's like reported numbers, I guess? Brand A has a min of 2 hours of battery life and a max of 7 hours. I'm trying to think. These all seem very low. Brand B, etc. So I feel like this is different people's reported data. Identify the shape of each distribution. I would call brand A relatively symmetric, but not fully. It's relatively symmetric until you hit these whiskers here. And this whisker goes from, it's like 4.75, man. 4.75 to 7. That seems to offset this one a little bit. Even though the interquartile range, it's relatively, oh, this one's hard to veg for sure. When I zoom out, okay, brand B, I see a right skew. The thing that concerns me on calling brand A right skew is although this is longer, it's not significant, and this part's longer than this part there. I almost want to call out symmetry. I think that whisker is long enough that it is offsetting that other one, and we can call it a right skew. I'm going to be in between on brand A. Brand A can be argued. I mean, you ask one person one thing, or if one person says one thing, the other says the other. It's kind of up in the air. Brand A could be considered relatively symmetric with a right skew influence. I'm really bad at interpreting that one, y'all, especially because that left half of the box is longer than the right half of the box. Brand B is right skew. Is skewed right. I have no argument on brand B, but brand A is that. That's part A. Part B, what is the range of the upper 75% of each brand? The upper 75%, we're talking that whole bit here, because this is the lower 25. The upper 75 is everything that is not the lower 25. Right? Am I saying that right? Or do they mean upper 75%? That sounds right to me. So the upper, yeah, I want to make sure that they didn't mistakenly say upper 25%. Okay. So, because I was thinking 75th percentile and things like that as well, and I got a little, Okay, so part B, what is the upper range of 75% of each brand? Upper 75 of brand A is going to be 7 minus 3.5, which is 3.5 hours. Upper 75% of brand B. This looks like 5.75, because here's 5.5, and that's halfway between. So 5.75 minus 3.25. Which is 2.5 hours. Part C, compare the interquartile ranges of the two data sets. So the IQR of A and IQR of B. I wonder if we have to make our own double box and whisker plot eventually here. I don't know. IQR of A. Q1 is 3.5. Q3 is, I'm going to say 4.75. So 4.75 minus 3.5 is 1.25 hours. 1.25 hours. I'll tell you what. I don't know if I did enough box and whisker. I don't think I made box and whisker plots, and I got to check my thesis and see if I did 5-number summaries. But the amount of information you can pull out of a single diagram and draw conclusions from is astounding when you're able to. Right now, we're just calculating numbers. We're not doing massive interpretations of this stuff. But the amount of things that you can get out of this stuff, like on my thesis, are dozens of pages worth of descriptions on things. So my thesis had something like this. I don't know if I drew any box and whisker plots. I probably should have. But I think I did a lot of 5-number summaries at the very least and brought up things within that. Anyway, which was about assessment feedback in high school mathematics. Okay, this is going to be 3.25 for the Q1 and 4.25 for the Q3. So I'm going to do 4.25 minus 3.25, which is 1 hour. Part D, which brand do you think has a greater standard deviation? Explain. Now, standard deviation was based off section 7.1. Standard deviation describes how far your values stray from the mean. Note that median and mean are not the same thing. However, something that has a greater range also likely has a greater standard deviation just because of how this stuff works out. So I'm guessing brand A has a greater standard deviation because of its range being more spread out. So brand A, I'm going to type, has a greater likely. Standard deviation is just a number, but it means a lot. It has a greater range overall, and substantially greater, right? It's not really close. It has a lower min and a higher max, and that max is significantly higher. Part E, you need a cell phone that has a battery life of more than 3.5 hours most of the time. Oh, this is the same battery. This is the same phone. Sometimes it does 2, sometimes it does 7. I guess is how they're saying it. Which brand should you buy? Explain. Or wait, has a battery more than 3.5 hours most of the time? The battery lives is so. Sorry, I'm still trying to decide whether they're talking about different batteries. This isn't answering the question. I'm just trying to figure out if they're talking about different reported cell phone batteries or a single battery for a cell phone. It would make more sense if it was the former, the thing I was talking about before. Anyway, you want more than 3.5 hours most of the time. So here's the thing. This might get some sets of getting to the 2-hour mark, which is in that lower 25% there, whatever. So there's some where it ekes lower, which is just unfortunate. But that's just only 25% of the time. Here, 50% of the time it's under 3.5 hours. And here, 25% of the time it is, even though it can get lower in that spread. This is 75% of the time it's above 3.5 hours. So you want brand A there. Brand A, because it's above 3.5 hours, 75% of the time. The only thing I have trouble with, I don't know if that means for my specific purchase it'll do that, or for my charges it'll do that. I don't know if this is different cell phones or the same cell phone. It's kind of hard to feel that out. Okay, number 22 is thought-provoking. Create a data set that can be represented by the box and whisker plot shown. Justify your answer. Okay, before there was a how do you see it question where I was like, I don't know if I want to do something like that. Here I actually will, because we have to. Now this is open-ended because you can come up with as many things as you want here. I'm going to finesse this a little bit, given that there's a number here. These are going by ones, and here this is clearly a 10.5. I'm not going to make 10.5 be one of my numbers. I'm going to make it be halfway between my two middle values, likely 10 and 11 could fit the bill. You could also do halfway between 9 and 12. But I'll probably have 10 and 11 be the middle numbers. And honestly, this might be easier to work from the middle outwards, so I don't have to kind of do a count from there. If 10 and 11 are the middle numbers, then there's an even number of values. So I need an even number of values filling out the rest. What I'll do here, I'll probably do like 11 numbers so that I can make 4 be the exact Q1, 15 be the exact Q3, and know exactly where to count that from on here. And I need my minimum to be 3. I need my maximum to be 18. So somewhere in between I need to be putting these numbers here. So, excuse me, I said I'd make 11 numbers. I'm having an even number of values. I'm going to make it 10 values total. So I'm going to make 5 of them here, 1 and 2, and I need 3 more numbers in between, where 4 needs to be the middle guy here. This is kind of weird the way that I'm doing this. I don't know if this is the best way to do it. And 15 is the middle guy here. Okay, I can probably fit 2 sets of numbers even still. Boom, 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 boom. Okay, I'm going to fit a couple more numbers. I'm going to put another 3 here. I'm going to put a couple 3s. 3, 3, 4, 4. Let's do 6, 9, and 10. Now here I'll do 11, 12, 12, 15. Let's do 15, 17, and 18. So let's see if this works. Clearly this is our min, our max, right? 3 and 18. We're all good there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 10 and 11 are the 2 middle values. Halfway between 10 and 11 is 10 and a half. And for the lower half, we have 7 values. Upper half, we have 7 values. The middle value of these are 4 and 15. That is our Q1 and our Q3. So that looks to be a set that we can use there. That's how I'm going to go ahead and do that one. So once again, in determining these by looking at my data. I'm not looking at the box and whisker plot anymore. I'm just looking at my data. The max is 18. Okay, cool. All right, one more question. Number 23, critical thinking. 2 data sets have the same median, the same IQR, and the same range. Is it possible for the box and whisker plots of the data sets to be different? Justify your answer. Yeah, totally. You can have a shift in really the box. A shift in the box. And the whiskers. They said the same range, not necessarily the same min and the same max. So let's do a double box and whisker plot with that in mind. So on 23, we can, first of all, the answer is yes. You can. And this is our last question too, huh? So let's kind of go all out. Do a bigger line there. I don't know if I need actual numbers, but I am going to be hitting these with different points here. So boom, boom, boom. I wonder if my tools have a number line option. I don't think they do. But even if they did, actually they might. Even if they did, I'd have to still work out scales. So, you know what? Let's come up with numbers so we can confirm everything is exactly as mentioned. Let's just do, this is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I want to make each range, let's say, be 6. Well, actually, here, 5, 1, 2, 3, 4. Let's go from 5 to 11 on this guy. Their IQRs need to be the same. Their medians need to be the same. I'm going to construct a median of 9. An IQR here from 7 to 10. So here's going to be one of them. So this guy's got, again, range is 11. 11 minus 5, which is 6. Median, IQR is 10 minus 7, which is 3. Say median. And median is 9. Let's do another one. I'll do it in green. I need the same median. Boom. I need the same IQR, but they can be different. So I can go, say, from 8 to 11 instead of that. Now, these things don't have to have the same min and max. They have to have the same range, though. So regarding this range, it still needs to be 6. Let's say that this one starts here and ends at 12. That still has 12 minus 6, which is 6. It's a different thing, though. So this one has a range, once again, of 12 minus 6, which is 6. It has an IQR of 11 minus 8, which is 3. And the median is still 9 within the IQR. Now, they never asked questions about, can the median and the Q1 be the same? Yes. Can the Q1 and min be the same? Yes. Things like that. And again, I'm representing these as min and max, not least and greatest values. My bad. That's just my thing. Guys, that was the last question, so a little bit shorter here. That ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. Hopefully we're understanding our 5-number summaries, box and whisker plots, yada yada. I could have imagined a lot more different kinds of questions they could have asked, and they refrained, which is always good for me, time-wise. And for you guys, if you're watching, hopefully you understood it. Thank you guys so much. Take care. I'm going to see you in the next one.